Hello, Honors Geometry. Mr. Rivers here. We're going to start this asynchronous lesson here going over section 2.1 perpendicularity. But before we do, I want to show you what I did to my OneNote, and I recommend you do the same. We've got a lot of stuff from chapter 1, right? So here under the teacher only area, this is where I would keep all my documents that I would push out to all of you. But it was getting really bogged down. And so what I did was I created a new subsection. You go down here to add section, right click, click in new section group. So if I'm read, for example, I'll click on assignments, I guess. And let's click on, let's see, new section group. And I was able to drag everything from my teacher only space into this chapter 1 area. I like to keep the newest stuff at the bottom and the oldest stuff at the top. However you want to organize yours is fine, but that's the way I like to do it. So anyway, right click, new section group. I called it chapter 1, and then I just dragged everything from chapter 1. It was up above here, so like let's say I wanted to move this Scala Brevis P7. You just left click, drag it down, and right there. So there you go. That would be the oldest item there at the top. I'm going to drag it back out because I want to keep it out of there. But that's how that's done with the new section group. So you may want to consider organizing your OneNote in that way just so it doesn't get too bogged down. If you want to just keep it going like you're doing it, that's fine too. You probably want to keep all your oldest stuff at the, no, I'm sorry, your newest stuff at the bottom because I think that's how it populates. Okay, I'd like you to find the section 2.1 notes, perpendicularity. They should be in your notes folder. I will distribute that out to you, so check your notes folder. Have that open while you watch this video. So section 2.1 covers perpendicularity. First off, the definition of perpendicular is lines, rays, or segments that intersect at right angles. You probably will want to pause this video if you need more time to write these definitions down. So if you need more time to write this down, pause the video. We have a symbol for perpendicular, and that symbol looks like this. It's like an upside down capital T. So that's the symbol for perpendicular. Perpendicular symbol. So when you see that, I want you to think perpendicular. So here are some examples here. We said lines, rays, or segments. It could be a combination of these as well. So here we have two lines. A is perpendicular to B. You see this perpendicular symbol there. So let's put a little right angle symbol there in the corner so we know that those are perpendicular to each other. By the way, if you have two lines or line segments or rays that cross like this, all four of these angles are going to be 90 degrees. If this one's 90 degrees, these two are supplementary, meaning their sum is 180. We have to have 90 and 90. Same thing for the other two. Here we have two line segments. DE is perpendicular to EF. Let's draw in the right angle symbol there as well, that little square in the corner. Oh. Okay, there we go. And finally we have segment JM perpendicular to ray GH. We've already got 90 degrees here in the corner, so that's good enough. Notice here we have a segment and a ray. Like I said, it doesn't have to be just two lines crossing or just two rays crossing or just two segments intersecting. It could be a combination of any two of these. On to example 1. I think you can do this one on your own, so pause the video now and try example 1 on your own. Okay, so if AC is perpendicular to AR, we have a right angle here. Okay, if AC is perpendicular to AR, which angles must be right angles? Angle CAR, or you might have called it angle RAC. And you might be looking at that saying, Mr. Rivers, it looks like that, oh, it looks like TAN, looks like that's a right angle. Well, remember, right angles can't be assumed. So while it looks like TAN might be a right angle, or it looks like TAB looks like it might be a right angle, we cannot assume that they are right angles. We need some sort of evidence or some sort of proof, and the only thing we know for sure is that AC is perpendicular to AR, so angle CAR is the only right angle we can identify there with certainty. Now, if I told you that TAN were a right angle, then you would also know that TAB would also be a right angle because those two angles are supplementary because they combine to form a straight angle, but we don't know that. We only know angle CAR is a right angle. Example 2, this is another one I think you can do on your own. Given that segment AB is perpendicular to segment AD, if the ratio of the measure of angle BAM to the measure of angle MAD is 11 to 9, find the measure of angle MAD. So try this one out on your own. I should add as well, write geometric statements. So if you've already paused the video and worked it, go back and write in the geometric statements that you used on this one. Well, my geometric statement is going to be the measure of angle BAM, which is going to be 11x, plus the measure of angle MAD, which is going to be 9x, is equal to the measure of angle BAD. And we know the measure of angle BAD is going to be 90 degrees because we were told that BA and AD are perpendicular to each other. So let's substitute in now 11x and 9x and 90. It looks like this. And we solve for x. 20x equals 90. X has to be 9 halves, or 4.5. Well, we were asked to find the measure of angle MAD. MAD is 9x, so we take our x, which is 9 halves, and we substitute it in for x. So the measure of angle MAD equals 9 times 9 halves. So the measure of angle MAD has to be 81 halves. 81 halves, which is the same thing as 40 and a half degrees, 40.5 degrees. So either of those would be acceptable. All right, or you might have said 40 and 1/2 as a mixed number. Okay, we are going to start getting into proofs this chapter. They were briefly introduced in the last chapter, but we didn't really do any outside of our notes. So this chapter we are going to start working in proofs. I'm just going to tell you right now, for many of you, maybe even most of you, this is going to be challenging at first. I want you to keep your head up, stay positive. This is brand new to you. You've likely never seen anything like this before. I want to tell you there is a pattern to this. You do see things used over and over and over again. It might take you a while to catch on to the pattern. It might be a week or two, maybe even more than that. But there is a pattern to this. Know that you are bright and you are going to stay committed to this, and in time you will figure out the pattern. So here we are given that NO is perpendicular to OT. So let's draw in the right angle symbol there at angle O. We're also told that YE is perpendicular to ET. So let's draw in that right angle as well. What are we trying to show? We're trying to show, or excuse me, prove that angle O is congruent to angle E. And you're probably looking at that saying, well, of course, angle O is congruent to angle E. They're both 90 degrees. They're both right angles, and you are correct. And we're going to put this in a 2-column proof format. And you may think, why would we do this? And it's because this is a very basic version of the proof. And if you can understand these basic versions of the proofs, we can build upon that with more complex versions that are a bit more rewarding than this one, okay? So the first thing we do with the proof, see if you can remember, we write down what? Write down the given information. So the given information is located right here, and the reason is going to be given. It looks like this. So NO is perpendicular to OT, and our reason is given. Our second statement is going to be our other given information. So that is YE is perpendicular to ET. That is also given. Okay, if NO is perpendicular to OT, what does that tell us? That tells us that angle O is what? Angle O is a right angle. So that's going to be our next statement. And I zoomed in for this one because it's kind of a small box, and so I had to write kind of small. Angle O is a right angle. We knew that because our statement in number 1, NO is perpendicular to OT. If you wanted to, you could have slid this statement above what we had listed at number 2. So in other words, you could swap 2 and 3 if you wanted to. That'd be totally fine. You don't have to. You can always write down the given information and then build from there. So how did we know that angle O is a right angle? Excuse me. Think about that. How did we know angle O is a right angle? Well, it's because NO and OT are perpendicular. So we're going to say definition of perpendicular. And there you see it, definition of perpendicular. All right, I think you can figure out what goes next. Pause the video and try it. Well, if statement 3 was angle O is a right angle, statement 4 is going to be angle E is a right angle. So that looks like this. Angle E is a right angle. How did we know angle E was a right angle? Look at the previous statement and the previous reason. It's the same thing. If YE is perpendicular to ET, by the definition of perpendicular, angle E has to be a right angle. So our fourth reason is going to be the same thing we had in 4, definition of perpendicular. Definition of perpendicular. Okay. Finally, are we able to show, or prove, I should say, that angle O is congruent to angle E? Are we now able to conclude that? And we are. So that's our final statement. Remember, whatever it is you're trying to prove is always going to be your final statement. Angle O is congruent to angle E. And you might not get this, but try to come up with a reason. Think about it. You have to write it down, but think about what that reason might be. How do we know angle O is congruent to angle E? The reason we're going to use is all right angles are congruent. All right angles are congruent. Oh, excuse me. Okay, so here's what I want you to know. These reasons that you see here, given, that's going to show up a lot. Definition of perpendicular, that's going to show up. All right angles are congruent, that is going to show up. So what did we do? We showed that NO is perpendicular to OT. We showed that YE is perpendicular to ET. That was given to us. If NO and OT are perpendicular, then O has to be a right angle. If YE and ET are perpendicular, then E has to be a right angle. And all right angles are congruent, so angle O is congruent to angle E. That is how you work that proof. Now there's one proof from your homework, and I'm going to work it with you now. So pull up your homework assignment. Okay, given A is perpendicular to B, so line A and line B, they are perpendicular. We are trying to prove that angle 1 is congruent to angle 2. Hint, this proof takes more than 2 steps. Remember, each reason should be a single sentence or less. So think about what it means for A and B to be perpendicular. It means they intersect at a right angle. Okay, so we know that angle 1 and angle 2 have to be right angles. How do we know that those are right angles? Well, it's because the two lines are perpendicular. And if angle 1 and angle 2 are both right angles, then they have to both be congruent. Think back to the problem we just did. It's going to be the definition of perpendicular is used, and also all right angles are congruent is used. So let's get going on this. Let's write statements and reasons. Statements on the left, and reasons on the right. Statement number 1 is always going to be your given information. It is A is perpendicular to B, and that was given to us. Okay. If A is perpendicular to B, we know that angle 1 and angle 2 are both right angles. So number 2, angle 1 and angle 2 are right angles. And that is the definition of perpendicular. What do you think we are able to go to next? Are we able to prove now that angle 1 is congruent to angle 2? We are, because if angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. See if you can remember the reason. We've seen it before. All right angles are congruent. Okay, there you go. And we'll take a look at number 7 together as well. Okay, number 7, we want to end up where we did in number 6, which was angle 1 is congruent to angle 2. All right angles are congruent. In the previous step, we showed that 1 and 2 are both right angles. Okay, so I tell you what, I'm going to let you do this one on your own. But we're given that ACB is 90 degrees, which means it's a right angle. Okay, and AD is perpendicular to BD, which means it's going to be a right angle. But there's some steps to show that. So think about what you can do to show that angle C is a right angle and angle D is a right angle. It says this proof takes more than 3 steps. So try your best on that one. If you don't get it, that is okay. This is brand new. That is expected. But give it a shot on your own. All right. Thank you very much for your attention, and good luck on the assignment today.